In this video, we're going to talk about combining polynomials. So first we're going to add x to the third plus 2x and 3x squared plus 5x plus 7. So when I add polynomials, what I like to do is write them so that I line up the terms that have the same powers on the variable. So I have x to the third. I don't have any x squareds in this first pair, so I'm going to leave a little blank. And then plus 2x. I'm adding 3x squared plus 5x plus 7. So I know that when I'm adding and subtracting, I'm combining like terms, which means that I can only combine things if they have the same variables and the same exponents. I cannot combine x to the third and x squared, for example, but I can combine 2x and 5x, and that would give me 7x. So when I add these, I get x to the third plus 3x squared plus 7x plus 7. The second problem says to subtract x to the third plus 2x from 3x squared plus 5x plus 7. And this subtract from is a little bit tricky sometimes for people. If I'm subtracting something from something else, this second thing is actually going to come first. So the wording here is that I'm doing 3x squared plus 5x plus 7 minus, put these in parentheses, minus x to the third plus 2x. So I'm going to set this up in the same way that I did earlier. 3x squared plus 5x plus 7. And I'm going to write like terms underneath in the same column. Now this is going to be minus x to the third, which does not combine with 3x squared, and minus 2x. It's important when you're subtracting that you're subtracting everything that's in the second set of parentheses, or everything that's in that term. So I need to subtract x to the third, and I need to subtract 2x from this polynomial. So when I put everything together, I get negative x to the third plus 3x squared. 5x minus 2x is plus 3x and plus 7. And then lastly, we're going to multiply x to the third plus 2x and 3x squared plus 5x plus 7. What I'm going to do is use the box method, which we saw earlier in the semester. Now for this, I have x to the third plus 2x. So those are going to go along one side of the box. Along the other side of the box, I have three terms. 3x squared, 5x, and 7. All positive. So then I'm going to go through and multiply the two sides of each box to get what I would write inside. X to the third times x squared, that's going to be x times x times x times x times x. So a total of x to the fifth. Or you might remember a rule that when you multiply things, you add the exponents. 2x times 3x squared is going to be 6x to the third. This is x times x times x, or x times itself 3 times. This box is going to be 5x to the fourth. This one is going to be 10x squared. This is going to be 7x to the third, and 14x. And then, as you remember from when we did this earlier, we combine the like terms. We have 3x to the fifth. We have 5x to the fourth. We have two terms that are x to the third. 6x to the third and 7x to the third. So we would add those together, and that's going to make 13x to the third. Be careful with this because you are adding the numbers in front, but you're not adding the exponents. So this would be 13x to the third, not 13x to the sixth. We also have 10x squared and 14x. Now, a lot of times we write polynomials so that we have the largest power first. You don't have to do that. It's not necessarily wrong if you don't, but a lot of times we like to know what the largest exponent is.